All right, Harmony Science Academy Honors Geometry students, welcome back. Section 1.25. The learning topic is similar right triangles. Here's some vocabulary. I'll go ahead and pause, let you guys do a little Google search, and let's go ahead and get into it, okay? Now, right out of the gate, let's go ahead and talk about this section. So the word similar is still in there, so the concept of similarity is in there. Triangle is in there last time, so it was so now we're tossing in the word right. Similar right triangle. You guys know what that is, so let's go ahead and draw something here like that. Okay. Let's make sure this is a right angle, okay? So we'll have A, B, and C, okay? So you might be thinking, well, what's the big deal? We did triangles already, similarity. Why deal with these guys? Well, there's special considerations with right triangles, and that's going to be the focus. Okay, so let's go ahead and just get straight into it. Okay, so here's what you need to know. When you have a right triangle, okay, what you can do is introduce this altitude, right? That's part of your vocabulary word. That altitude, okay, starts here basically on the hypotenuse, and what it does produce 90 degrees here and here, okay? So here's a couple of consequences, okay? That means that at the moment that we drew this altitude, we've got the big triangle, this triangle, and this. We've got three triangles, and guess what? All three of them, in this case, because we're dealing with the right triangle to start off with, they're all similar, okay? So let's call that D, okay? So I'm not going to write out those details because you guys know the symbol for right triangle ABC is similar to BCD is similar to ABD, okay? So there's that part, okay? You want to put what I just said in your notebooks, okay? So the three triangles in this case are guaranteed each time to be similar. So all the properties that we talked about last time, right? Setting up the proportions, that still applies. The angles, okay, ultimately will match up. Corresponding angles will match up. They'll be congruent. So a lot of information that you'll have available, okay? So yeah, okay, and I guess it's so valuable, let's go and list it here, okay? So we'll say that triangle ABC is congruent. I didn't want to write it, but actually, more important than congruent, similar. So let's start over. ABC is similar to triangle BCD is similar to ABD. Okay, this is that powerful, right? You can set up all these proportions if they're asking you to solve stuff. You can set up corresponding angles, know that they're congruent. Just awesome, okay? So it's, again, I wouldn't write it if it wasn't that important. So what else can be said, okay? With with the use of these right triangles, it's going to allow us to use something you should have learned, geometric means, okay? If you don't remember that or weren't taught that, here's basically what a geometric mean means, okay? So let's say you have some number, A and B, okay? And just so you don't relate it to this, I'll call it R and S, I guess. R and S. Okay. If we go ahead and put in an X, okay, here in the denominator, here in the numerator, and they equal each other, that means that R and S have a geometric mean, which is X. Okay, this special X is a geometric means which allows these two ratios to be equivalent, okay? So you can produce a relationship between R and S because of x. Okay, all right. So with that said, okay, we're gonna actually use a geometric mean. Okay, the knowledge of geometric means in this lesson. Okay, so everything else you guys already know from the previous lesson is going to apply, plus there's additional information. Okay, so let's talk about that. There's two corollaries. Okay, so we'll say C1. So when you use C1, here's basically what you're saying. Okay, is that we can take this distance, or let's just, well, yeah, let's go ahead and just make it clear. You can take this distance and this distance. Okay, so we can take AD, okay, and create a geometric mean scenario, and DC. Okay, and who's going to be the geometric mean? It's going to be the altitude. Okay, right here, which is BD. Okay, very powerful. So again, what is it that's happening? They're going to ask you to solve different triangles, right? And there might be information given where you can't go the standard version, or they're giving us another tool here. So we can say that AD and DC have a special relationship through this BD, right? This altitude serving as a geometric mean. Okay. Again, all this will apply all the time as long as you start off with a right triangle. Okay. So that's corollary 1 and corollary 2. All right. Let's go ahead and discuss this one. So we have a relationship between him and him. Okay. For corollary 1, for corollary 2, we're going to have a relationship between A and C and A and D. Okay. So A and C, A and D. And the question is, who's the geometric mean? Okay, in this case, we've got AC, AD, and it's going to be this guy right here, AB. Okay, think of it this way. You've got the hypotenuse, the leg, and the side that's adjacent to that side is going to be, you're going to use as a geometric mean. Okay, so you might have to watch this a couple of times. Nothing wrong with that. Okay, but that's why I make the videos. And check this out, since we went long and short, we can also go long and this other short. Okay, so I want you to think about it. You can pause the video. So if I go AC, all right, and I want to produce a relationship between AC and DC, pause the video and think for a second, who would be the geometric mean? Okay, good. If you said, hey, well, here's the hypotenuse, here's the leg, it should be the adjacent, and it's BC. Okay, so BC. So you definitely want that in your notebooks. You definitely want to watch this a couple of times and really appreciate that information. Okay, so let's go ahead and get into it. Let's go ahead and again, I don't know ahead of time what problems use what and what doesn't. So let's go ahead and just start off with one, and we'll try a couple of these problems. Okay. All right. So we're looking at 1, and I've got, right. If it helps, we can maybe label these bad boys like this. A, B, C, and D. Just so it'll help us talk, and it'll help you guys kind of talk through it here, okay? So I can see that I'm given this hypotenuse, right? 4. And I'm already thinking ahead that this 4 can be compared to who? This 3, right? And who would be the geometric mean? It would be the what? Hypotenuse, the leg, adjacent, so x. Okay. Now again, of course I have a little more experience, but you're gonna have to kind of look at them, try it with the knowledge you have. If you can't, then you want to go about it this way. Okay, so the question is, which corollary was this? And This would be corollary 2 if I'm not mistaken. Okay. So now cross multiply, we get 12 equals x squared. Take the square root of both sides. Okay, and you're left with you'll probably have to go calculator at this point. Okay, not sure if we covered it in this class. Actually, I think we did. Okay, so I'll just do a quick review. You break down the 12 into, or whatever values in here, into its prime factors. So 2 times 2 is 4, times 3 is 12, and you circle the pairs, and that's what comes out. Okay, so think of it this way: square root of 4 is 2. This guy doesn't have a pair, so he stays inside. Okay, so that's it. That's pretty much the lesson. So let's go ahead and travel. Okay, you guys want to practice all the way up through 8. Let's see here. Let's go ahead and try. Let's see here. Let me look for one that maybe is a little more useful. Okay, I guess we won't stray too far, and we'll go work on 9. Just FYI, 1 through 8 should be the simple version. 9 through 14 medium, and then the last 4 should be a little more advanced. Okay. All right. So again, you're gonna get by now you should be more comfortable once you got some practice up there. I'm looking at this and I'm seeing that I've got x and 25, and there's other methods. Okay, but if I'm looking at that first corollary, that's what strikes me here. Is that I can compare what? X and the 25, okay, by using the geometric mean, this altitude, okay, 25 square root of 3. Alright, so at this point, the 25's cancel here. Alright, I've got the setup. Okay, remember what it says, I can compare him, and the geometric mean is this bad boy here, this altitude. Okay, so I've got it set up. Now it becomes an algebra problem. Okay, so I'm going to go ahead and I've simplified there. I'm going to take this, I'm going to multiply both sides by 25 square root of 3. Okay, so it will cancel here, and over here I have a square root of 3. So just so you guys can see it. Okay, in case some of you guys need some practice with some of this algebra, this would be 25. And when you have multiplication, you can combine them inside the same radical, because this is a square root, this is a square root, so you can combine them. That's 9, so the square root of 9 is 3, and 3 times 25 is 75. Okay? Alright guys, we'll go ahead and get some practice in class and answer any questions. Okay?